this property of logarithms is something that we actually worked with in the last section, really meaning that if we've got two numbers are equal, then the log of some set base of one number is equal to the log of that set base of the other number. That worked out, like, for example, with that problem where we had the log to some base of x was equal to the log of some base of 8, well, then x and 8 had to be equal to each other. This lesson actually introduces using logarithms to solve exponential equations. So just like we could add a number to both sides of an equation, just like we could subtract a number from both sides, we can take the square root, we can square, we can multiply, we divide. We can also take logarithms to two sides of an equation. Now, you can use any base if you'd like, but the truth is you're going to want to either use the natural log or the log to base 10 because you can put those in your calculator. So what you'll end up doing is you'll take the natural log of both numbers, right? So we have natural log of 8 to the power of x is equal to the natural log of 21. And that actually shows that rule, that if these are equal, then those are equal. Now, we know that rule regarding exponents. That exponent can come down to the front, so we end up having x times the natural log of 8 equals the natural log of 21. Well, now we just follow our basic rules of algebra. We can divide by the natural log of 8 on both sides. And then we can put this into our calculator, being careful regarding the parentheses. When we do that, we get that x is equal to 1.464. Let's take a look at the next one. Again, we have exponential equations that we're trying to solve. So what we'll do is this time I'll take log base 10 of both sides. Why am I doing that? Because I want you to see it. You can, if you want to stick with one or the other, that's fine. So I'll take log base 10 Now those same rules with the exponents are going to apply. So we have 2x minus 3 and then x plus 1. Alright, so from here, we're going to distribute this log 5 to both terms in parentheses, and then the same with the log 8. So this becomes 2x log 5 minus 3 log 5. Oops, how about I actually spell that correctly? And that's equal to x log 8 plus 1 log 8. So we'll just write that as log 8. What I want to do now is I want to collect all these terms that have an x in it. So I want this term and this term on one side of the equal sign, and then I want these two on the other. Okay, so what I will do is I will subtract this from both sides, and then I'll add this one to both sides. That gives me 2x log 5 minus x log 8, and that's equal to 3 log 5 plus log 8. So now you might be thinking, well, why on earth did we bother doing that? Well, now I can factor this x out, and I'm going to come up to the top over here to finish this problem. So I factor out the x, and now, because I'm multiplying x times this term, I can divide both sides by this. So that gives me x equals 3 log 5 plus log 8 over 2 log 5 minus log 8. So then we use our rules again, and this becomes the exponent here. The 2 becomes the exponent here. Now I enter this into my calculator, remembering to put parentheses around each numerator and denominator. And when I do, I get 6.062. Now, anytime you're dealing with something that has e, you have to use the natural log. So what I'll do is I will take the natural log of this first equation. So I get natural log of e to the absolute value of x is equal to the natural log of 50. Now remember that natural log is base e, and one of those things that we learned is that the natural log cancels out e, so we end up with absolute value of x is equal to the natural log of 50. If I plug natural log of 50 into my calculator, I get 3.912. So x is equal to approximately positive or negative 3.912. Taking a look at the next problem, we have to remember our rules of exponents, right? Same base, and you're multiplying, so you add your two exponents together. That means that I have e to the 4x plus x minus 1 is equal to 5e, and that's e to the first. So when I combine what's on the left, e to the 5x minus 1 is equal to 5e to the first. If I divide by e on both sides, now I subtract. Okay, this stuff keeps popping up and I can't quite make it go away, so we're just going to delete. Because this is not right. So now, that's all done. When I actually subtract my exponents here, I get e to the 5x minus 2 is equal to 5. Then I take the natural log on both sides. The property says I need to move this out in front, so I have 5x minus 2 times the natural log of e is equal to the natural log of 5. Cool thing about natural log of e, it's equal to 1. I'll add 2 to both sides. And I will divide by 5 on both sides. And from here, I will put the rest into my calculator, making sure to put my numerator in parentheses. And I get that x is equal to 0.722. Alright, for this next problem, we need to remember again our properties. If you have the two logs with the same base that are being added, you can multiply these components together. So here we would end up with the log, which is base 10, of x times 2x plus 1 is equal to the log base 10 of x plus 8. What that means is that these terms then have to be equal to each other. So x will get distributed, and we'll have 2x squared plus x is equal to x plus 8. Now all I've got is a quadratic, so that's simple enough for me to deal with. I'll bring everything over to the left and set it equal to 0. This gives me 2x squared minus 8 is equal to 0. Factor out a 2. Come up on the side here. When I factor, I have a difference of squares. So that means x is either equal to -2 or +2. Now, we did figure out that we don't take logarithms of negative numbers, so really x is only equal to 2. This next problem is similar with one difference. Rather than this being the log of something, it's just a number. So what we have to do is we need to rewrite this as the log base 2 of something. So I'll say off to the side here, log base 2 of what equals 3. We know how to do all this rearranging. That's 2 to the third power equals what? And that what is 8. So I'm going to rewrite 3 as log base 2 of 8. Now, this problem looks like that problem did, and we're going to go through the same process. This is being added, so we'll multiply these together. And I'll FOIL. Now, since my logs both have the same base, that means this whole thing has to be equal to 8. So I'll rewrite it. And I'll subtract 8 from both sides. From here, I'm going to have to use quadratic equation. And that gives me 11 plus or minus the square root of 65 over 4. But again, I have to remember logarithms cannot be negative, so I'm really going to take 11 plus the square root of 65 over 4. And this is your last problem. The first thing that's going to throw you off is this natural log of e to the natural log x. So what we have to think about is the fact that e to the natural log of x is just equal to x. So I'm going to take this and just replace it with x. Now I'm going to use all my properties of logarithms. Same base, subtracting, so I will divide this by this. Same base, which means this has to equal this. Clear my denominator by multiplying on both sides. So I will bring the 20 over, and I'll bring the x over. Divide by 4. And we discovered that x is equal to 5.